These notes are for lesson 7.1. This lesson is on finding rational solutions of polynomial equations. But before we get started in that, I just want to do a little bit of vocab. So we've talked about solutions to an equation. So if I have some equation like this, the solutions is some x, we'll call it x prime, such that when I plug that x prime in, the equation is satisfied. In this case, it would equal 0. This same x will also act as a 0 to a function. So remember, the definition of 0 is if I have some function this is an x, such that when I plug that x into my functions, let's write it this way. It comes out to be 0. And you can see clearly that if I have, the polynomial is the same, that would give me the same, would be the same value of x. We also have talked about x-intercepts of a graph. So let's say we have the function here. The x-intercepts happen when the y-coordinate is 0. So that's equivalent to finding the x's such that this, and you get in this case that the same answer as the solving, which we also saw was the same answer as the 0. And then we have also the term roots of a polynomial. So if I have some polynomial like this, the root is a value of x such that x minus the root is a factor. And we've talked about factors. So a factor of this polynomial is some other polynomial, such that when I divide it, I get a 0 remainder. Well, it turns out that I can take an x-intercept or a 0 or a solution, and I can translate those x's into a root or a factor. And then you see that there's not much difference between roots and factors. So that's one of the big ideas that we're going to be using here. So for example, if I solve this thing, I'd get x equals 1. And we can check just by inspection that 1 minus 2 plus 1 is indeed 0. If I take that and I just subtract 1 from both sides, this is my factor, and it's also, in this case, the way it's written, also a root. Oh, good. So that's easy enough to do. So in the last section, we did problems where we said, oh, you need to be able to factor things like x cubed plus 2x squared plus x plus 2 if we're asked to factor things like this. And this you could do, you'll notice, just by grouping. And then we said, well, what if we had something that we couldn't factor by grouping? So what about something like x cubed plus 6x squared plus 11x plus 6? You notice if we try to factor this by grouping, we're going to fail, because if I take from the first group, I can take out an x squared. In the second group, I can only take out an x, or a 1, and you'll see that these factors are not the same, so we're stuck. So what we did in the previous section was we gave you some additional piece of information. We told you a factor for this. So this would be a piece of information that was given in the problem. And now, since I have this, I can factor it by using this synthetic division. So what that division allowed me to say is that x cubed plus 6x squared plus 11x plus 6 factors 2, x plus 1 times x squared plus 5x plus 6. Again, the remainder, constant, x coefficient, x squared coefficient. And then this piece I could factor using my factor entry, and it just factors to x plus 2, x plus 3. Now the question becomes, what would you do if you're given x squared plus 6x, x cubed plus 6x squared plus 11x plus 6, and you weren't given a factor for this? That's what we're going to seek to address in these next 2 sections. So, we have a couple of tools. The first is the rational roots theorem. And what this says, it says if a polynomial that I'm going to call p of x has integer coefficients, then every rational root of p of x equal to 0 can be written in the form m over n, where m is a factor of the leading coefficient and n is a factor of the constant term. I have that reversed. That's a problem. So n is the factor of the leading coefficient, and m is the factor of the constant term. Woo! That would have been a close one. So let's go back to this problem that we've been looking at and see what that says, or how we can use the rational roots theorem. So the leading coefficient is 1, and the factors of 1 are just 1. M is the constant term, that's 6. The factors of 6 are 1, 2, 3, and 6. And really our textbook is dumb. They really should say plus or minus m over n. So my possible rational roots are plus or minus a factor of 6 over a factor of 1, plus or minus a factor of 2 over a factor of 1, plus or minus a factor of 3 over a factor of 1, and a factor of 6 over a factor of 1. So here I have 8 possible rational roots. Why 8, you might ask? Well, I have, because of plus or minus, each of them counts as 2. Right? Because I have positive 1 and negative 1, positive 2, negative 2, etc., etc., etc. So that's a lot better. We went from this having like infinitely many possibilities to this having now 8. That's a little bit better, but 8 is still kind of a lot. Well, could I narrow this down a little bit? Yes, I could. So the way I'm going to narrow this down a little bit is to use my graphing calculator. If it will load for me. Not load twice. So what I'm going to do is I'm just going to go to the y equals. I'm going to clear out anything that's in there. And I'm going to type in my equation, or my polynomial that I'm trying to factor. I'm now going to change my window. So my x min should be a little bit smaller than my minimum possible root. So in this case, the smallest one is negative 6. I'm going to put like a negative sign. Likewise, my x max should be my biggest, a little bit bigger than my biggest one. My biggest one is 6, so maybe I'll write a 7. And the y min and y max doesn't really matter. I just need to be able to see the x-axis, so my y min needs to be negative and my y max needs to be positive, but it doesn't really matter what those are. I just need to see where things are crossing. And why is that going to be important to me? Well, remember earlier we said that x-intercepts are really the same thing as zeros or solutions or factors or roots. So if I can see where the x-intercepts are, that tells me which one of these values of x I could use to do my division. So I notice that I see some crossing going on here, but it's too blurry for me to really make this out. So I'm going to readjust my window by zooming in. It looks like this is maybe negative 3, and this looks like maybe negative 1. So I'm going to refer this to just negative 4 to 0, a little bit smaller than negative 3, and a little bit bigger than negative 1. And similarly, I'm going to shrink this down so that I get a better view of kind of what's going on. And how did I pick -2 and +2 there for the y's? I just guessed. And I got a pretty good look. So it looks like we're crossing at -3, -2, and -1. So what I see is, oops, come on. When I use my calculator, oops, that's going the other way now, isn't it? I did this. I get this. So I have x-intercepts at x equals -3, -2, or -1. So these look like, then I go to my list and I say, aha, well, I have -1, I have -2, and I have -3. Any one of those would be a good starting spot, so I'm just going to arbitrarily pick -1. So I'll do my synthetic division. And bingo bango, I found a factor. So if x equals -1 is an x-intercept, I know it's an x-intercept because it gave me a 0 remainder. What that tells me is x plus 1. If I add x to, or I add -1 to both sides, is a factor. So I can say that x cubed plus 6x squared plus 11x plus 6 is equal to x plus 1 times my leftovers, x squared plus 5x plus 6. And then I could go and use one of the other ones that I have, or I could just use my factoring tree techniques to do that, and that's what I would do. And again, as we observed earlier, that this factors to x plus 2, x plus 3. We did that earlier. So let's look at another example that's maybe a little less straightforward. So let's look at another example. Let's say we're asked this time, instead of factoring, to solve. And what we're asked to solve is x to the 4th minus 2x to the 3rd minus 6x squared plus 7x plus 6 equal to 0. So in order to solve this, what I want to be able to do is write it in a factored form and then apply the zero product property and solve each one of those factors independently. Unfortunately, I'm not told any factors for this polynomial. So what I'm going to do is I'm going to use that rational roots theorem. I notice the leading coefficient is 1, and the factors of 1 are just 1, and the constant term is 6. The factors of 6 are 1, 2, 3, and 6. So my possible rational solutions are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 3 over 1, and plus or minus 6 over 1. What I'm going to do next is I'm going to go to my graphing calculator and take a look at what I have. So I'll go back to the y equals and I'll type in this exactly as it's written. So x to the 4th minus 2x to the 3rd minus 6x squared plus 7x plus 6. And I'm not going to worry about the equal 0 part. And then I'm going to go to my window. Well, I know that, again, my smallest possible x-intercept or 0 or solution or factor was -6, so a little smaller than that is -7. The biggest one was +6, so I'll pick +7. And then I'll just keep this -2 to 2. Again, it doesn't really matter as long as 1 is negative and 1 is positive. That's going to be okay for your y's. Let's hit graph and see what's going on. So it looks like I have here at -2, -0.5 maybe, 1 and 1.6 maybe, and then 3. Already forgotten. -2, -0.5. Positive 1.6, and then positive 3. So if I go and I compare these, I notice that -2 I have. This though I don't. This though I don't. And then positive 3 I have. So what is this saying about these guys? It's saying they're not rational. So that means they could be irrational, which probably means they involve a square root, that particular solution. But that's okay. We can get those still. But we're going to use, say, this one to start with. So I'm going to start my synthetic division. 1, -2, -6, 7, 6. Okay. Bring the first one down. Oh, yay! So what I have then is x plus 2. That's this piece, and then x cubed minus 4x squared plus 2x plus 3, that's this piece. Now I'm left to try to factor this, or solve this. Stuck in the same place, like, can't factor this by grouping, I don't know any factors to it, but I do know that any possible factor of the original polynomial could be a possible factor for this one. I still have one that I haven't used yet, 3, so I'm going to use 3 on this piece. Yay, 0 remainder again. So what that says then is I had x plus 2 times x cubed minus 4x squared plus 2x plus 3. But this piece I could break further up. The x plus 2 is going to come down. I'm going to get an x minus 3, and then an x squared minus x minus 1 from that piece, all still equal to 0. And if you'll notice, if I go back to my list here, I'm out of rational zeros. All I have are these things that aren't on the list. But it's okay. I can apply the zero product property here. I have x plus 2 equals 0, x minus 3 equals 0, and then x squared minus x minus 1 equal to 0. And I'm going to have no problem solving, because even here I can use quadratic formula. Since that's a quadratic equation, I end up with 1 plus or minus square root 5 over 2. And if I go to my calculator and I type in these, so 1 plus the square root of 5 over 2, that's about my 1.6. And then if I do 1 minus, that's about my -0.5. Oh, okay. So that's not so bad. What if we do this one next? So suppose we're asked now to solve x to the 4th plus x cubed minus 6x squared minus 14x minus 12 equal to 0. Again, it's going to start the same way. I'm going to start with that rational roots theorem. And my leading coefficient is 1. The factors of 1 are just 1. My constant term is 12. The factors of 12 are 1, 2, 3, 4, 6, and 12. So my possible rational solutions are plus or minus 1 over 1, 2 over 1, 3 over 1, 4 over 1, 6 over 1, and 12 over 1. And to weed that down more, I'm going to go to my calculator. I'm going to type in my equation. So x to the 4th plus x to the 3rd minus 6x squared minus 14x minus 12. And I'll change my window again. So my biggest and smallest x is negative 12 and positive 12, so I'll go negative 13, positive 13, a little more, a little less. And hit graph. So it looks like negative 2, and then positive 3. Okay. Well, let's just pick one. Say we pick negative 2. And we'll go ahead and do our divisions. Yay. So we have then x plus 2 times x cubed minus x squared minus 4x minus 6. Again, that comes from there and that comes from there. Now we'll take our positive 3 and this stuff and try factor some more. Yay! So what we have then is x plus 2 and x minus 3 and an x squared plus 2x plus 2. But I'm out of factors or possible rational solutions to use, and I still have some stuff left. Well, what's going on here? Well, maybe we'll just try to solve and see what happens. So I use the zero product property, and I get x equals negative 2, x equals positive 3, and this I'd have to use the quadratic formula for. So when I do that, I get negative 2 plus or minus 4 minus 8 is negative 4. The square root of negative 4 is negative or plus or minus 2i. If I reduce that, that's negative 1 plus or minus 1i. Aha! That's why I couldn't see any more roots on my graph, is because they were imaginary. Oh, interesting. So I think at this point, you've seen kind of all the different possibilities that you need to, and you should be good to try some of the homeworks.